Okay, can you see my screen? I can see myself. Okay, so perfect. Now, yeah, so today I would like to talk about PHPAnchor SDK. And the PHPAnchor SDK is a new project that we are building. So our team consists of 2 developers, Benz and me. And we are StellarDevelopers. Benz is a Stellar developer since 2021, and I'm a little bit longer, since 2017. And the topic today is about anchors. And as you probably all know, anchors act as a bridge between outside currencies and the Stellar network. So assets can be, anchored assets can be, for example, fiat currencies, crypto, stocks, bonds, and so on. And the standardized communication between Stellar clients, such as, for example, wallets and anchors, is defined by so-called Stellar ecosystem proposals. So clients and anchors must implement those Stellar ecosystem proposals so that they can communicate with each other in this standardized way. So, and what is the PHPAnchor SDK about? So the PHPAnchor SDK's goal is to help Anchor developers to implement this interaction. So client-Anchor interaction from the Anchor perspective. So it tries to abstract as much Stellar-specific functionality or logic as possible from the defined Stellar ecosystem proposals so that developers can focus more on implementing the business logic of the anchor, for example, the payment rails to banks. And for anchors, the most important Stellar ecosystem proposals are these. So SEP-01, SEP-10, SEP-12, 24, 38, 6, and 31. And they define different use cases. For example, SEP-1 defines a standard way to expose information about the anchor. SEP-10 defines the way how clients can authenticate with the anchor. SEP-12 defines how the know your customer process should be handled in a standardized way, and so on. So, and today I would like to show you what we already achieved with the Stellar PHPAnchor SDK, or a part of it, with a short demo with Postman, and then we are going to look into how this is implemented, how it can be integrated into an Anchor implementation, in a server implementation, and what advantage it brings to use the PHP Stellar SDK. So first I would like to show you this image. So as you can see here, this is like the server implementation and Anchor implementation. And where is the PHP SDK? The PHP SDK is integrated into this implementation by dependency. And when clients make requests that are related to the Stellar ecosystem proposals, these requests are forwarded to the PHP SDK, the PHPAnchor SDK. It handles as much as possible from them and sends the result back to the client. If there are things that it cannot handle, then there are callbacks to the business logic, which are then called so the anchor can execute this business logic and respond to them. And now let's have a look to our. So I have a server running here, our reference server. So the Anchor PHP SDK is built up of 2 components. We have one, the SDK, and another component that we have is the reference implementation, the server reference implementation, which is also very helpful because Anchor developers can see how the PHP SDK is integrated and how they can handle the data. So now I have here about the first SEP, the SEP-01, which allows anchors to expose information about them. So if we send a request here, we can see from our reference server some information and for example, which assets it offers. But for us, the most important part is here, where can we authenticate with this server? And this is exposed here in the web-out endpoint, which is defined in the SEP-1 TOML file. So we can go and try to authenticate as a user here with this endpoint. So for this, I just want to show you a short introduction to the SEP-10 web authentication. So what happens here is that a client, for example, a Stellar wallet, requests web authentication challenge from the server, which then composes a Stellar transaction and sends this transaction based on the request parameter, sends the transaction to the client. The client has to validate the transaction so that it is really coming from the server. Then it can sign the transaction, post it back to the server. Now the server can validate if this transaction has really been signed by the user. So the account, he is really in the possession of this account. And if that's true, so if all signatures are true and everything else is correct, then the server generates a GVT token, which is then sent back to the client. So this Stellar ecosystem proposal is defined here. Probably you know it all. So, and it defines exactly how the interaction works and how, for example, the challenge. So these are the request parameters. And for example, how should the transaction, the Stellar transaction, how should it be built so that it conforms to this standard, to this Stellar ecosystem proposal standard number 10. So here you can see it's a lot of Stellar logic, which has nothing to do with, for example, payment rails. So, and this can be implemented in the Stellar PHPAnchorSDK. So it can be reused by the anchors and they don't have to implement this logic again and again. So now let's see how this works. So now we can maybe remember here, we have we request a challenge. We get the transaction back as a response. Then we have to sign it, send it back to the server, and then we will receive the GVT token. So now I'm going to create a new account. Like this. This account is not existent right now. So it does not exist on the Stellar network, but the SEP defines that these accounts which are not existent on the Stellar network should also be processed. So let's have a look. Now the user wants to authenticate with his account ID. A request is sent to the out endpoint, which we've seen here in the TOML file. And as you see, we get a response from the server with the transaction, which was composed by the server for the client to be signed so that the client can prove that this account really belongs to him. So if we are looking now to this transaction, we can see how it is built. So it has a sequence number of 0, so it cannot be executed on the real network. And it has different manage data operations. Of course, our account does not exist. And it implements the specification of SEP-10, how this transaction should be built. Okay, now next we are going to take this transaction and sign it with the secret seed from our new user, from our new account. And we can sign it here. This is the signed transaction now. And this signed transaction we can now send back to our server to prove that this account belongs to us. So as we can see here, now we are posting this signed challenge to the server to receive the GVT token that we can then later use for different other use cases, such as, for example, to send customer data. Okay, now this transaction is here, signed. The server validates the transaction, validates the signatures, and so on. And if everything is right, then it gives us the GVT token. And all this process is done by the PHP Anchor SDK. So there's not a big need for the Anchor developer to implement this. It just has to integrate the Stellar SDK. Now, the token can be used, for example, to request customer information, to upload customer information. We can use this token in the next requests. For example, now we want to use here the token to get the customer information, which of course is not existent because this customer is completely new. So we will get the information that here we need, that the anchor needs information, such as he needs the first name, the last name, the email address, and so on. So now let's go back to the SEP-10. I would like to show you how this is implemented in the PHP SDK and how we use it in the server. So here you can see in the reference server we have the composer file where we add this dependency to the PHPAnchorSDK, and now we can use the PHPAnchorSDK. And to use it, we have to define the root. So, for example, the root for the Stellar Web Authentication is as we defined out. So like we have seen here, we defined that our root is out. So we define here in the root that there are two. One is get. So this will be used to get the challenge, and the other one is post, where we use it to send the signed challenge. And these two roots, they go to a class which is called StellarOutController, which is implemented here in the reference server, and it calls the method out. So the request is sent to this controller, to the method out. And now we are going to look to this controller. This controller receives the request. Now it prepares necessary data for the SEP-10 service, which is part of the PHP Anchor SDK. And here we can see the description, how to use it. And this SEP-10 service needs a configuration. So let's have a look, what is this configuration about? So let's first have a look to this SEP-10 configuration. So here we define different things, like such as, for example, how the authentication timeout, the GVT timeout, the signing key, so the server signing key has to be given to the SDK so that it can sign the transaction. Then the GVT signing key has to be given to the server so it can sign the GVT token. So here are some configuration settings that we can implement. This is an interface. And so we did here, this class implements the SEP-10 config, and here we provide the corresponding data to the PHP SDK. So now the other one, let's go back to the controller. So the other one is a very simple configuration. It's about, it just contains the network to be used. This is an app configuration because it is used in different use cases. So here we just receive the Stellar network that is used and the Horizon URL to be able to make requests to Horizon to get the data. For example, we need this when the account already exists in the Stellar network, and then we have to prove if the signature of the transaction is enough. So it means if the account has the right threshold configuration to allow the signing. I will show you this later. So, okay, now we have this controller. We defined the configuration that is needed. We initialize the service, and now we send this request, which we received here, directly to the service, and this handles the request for us. That's it. So now it handles the request, generates the transaction, validates the request, and returns the response. So that's all we have to do here to implement SEP, to integrate the SEP-10 web authentication. Now let's have a look here a little bit. So now, depending on which method is used, so get is like we've seen here, get is for the okay. Okay, get is for to get the challenge. So we go here to create a challenge, and if it's a post request, then we know, okay, it's we have to handle the validation request. So we have to validate that the challenge has been signed by the user. So here creates the challenge, it validates the data, and now you can see it has different steps of validation. It composes, it extracts the data that it needs, and then it creates the challenge. So here we also have different kinds of. So here it composes the corresponding transaction so that it can be sent back to the client. And that's it. So now this transaction is sent back to the client, and then the client verifies the transaction, and next step is that it posts the signed transactions back, and it has different possibilities to send that. It can send that with different types, for example, JSON, and so we have to extract the data here, the request data, and now we can handle the validation requests. We parse the challenge, also validate the data which is in the challenge. So we have to validate if this transaction corresponds to what we send to the client. So there are a lot of checks here. If the sequence number is 0, if the time bounds are okay, if there are at least one operation, if the first operation is a managed data operation. There's a lot of Stellar specific checks that have to be done here. So you see there has to be a nonce in it and all this validation. So the Anchor developer, by using the Anchor SDK, does not need to know all this stuff, and also to implement it over and over again. So it can just use the SDK to do so. So after this is validated, after the data is validated, we can now it also, of course, it also checks if the signatures are okay. So for example, here we check the signature for a non-existent client account, and here for existent client account, which we will see later. And then after everything is checked, if it was signed by the server, if it was signed by the client, and everything is correct, then we are going to generate the GVT token, which is also done by the SDK. And this GVT token is also signed by the SDK and sent back as a JSON response to the client. So as you can see here, this is the integration in the reference server of our service, which is implemented in the PHPAnchorSDK. Okay, now let's have a look to another example here. So let's create an account. Create a new account. So we create two accounts. First, we take this one. So now this account exists on the testnet, on the Stellar testnet. Let's put this here. And now let's create a new account. We also give them some lumens. Now what we are doing next is to make this account, to configure it in a way that the signing key is not allowed to be the only signer for identifying that this account belongs to him. So we are going to create a transaction, build transaction for this account, which is called set options. And what we do here is we set the low threshold to, let's say, 1, the medium threshold to 10, which is the important part here, and the high threshold to 20. And now the master signing key should have only 5, so it will not be able to sign transaction with a medium threshold. And also we will put here a new signer, which is our second account. So, and this also gets 5. So now together they can, with both signature, they can prove that this account, they control this account, this first account. So let's sign this transaction. Now we sign it with the key from here. And submit it to the network. Oh, was wrong. Something is wrong. Let's see. So this one is FA. No, it was the wrong one. Let's do it here. Okay. Set options. We have the master weight, the medium, and the other one is this. Okay. Sign transaction. Now it should be the correct signing key. Okay. Okay, now what we have now is that this account is not able to prove with his signing key that he is the owner of the account in terms of the medium threshold. So because if we look to the signers, it only has a weight of 5, and the other account has another weight of 5, so it cannot sign transactions that need the medium threshold. So now if we go and try to authenticate with this account with SEP-10, we receive the transaction, and now we sign it only with this one key. So with the key from here, from this account. So I just take this one. Now we have a signed transaction from this account, but this should not be enough because it has not enough weight. So let's try to send it to see what happens. So the PHPAnchorSDK finds out that that's not enough. Okay, so then let's try to sign with additionally with this other signer. Then it should be okay. Now change that. And now we get the token. So there's a lot of Stellar specific logic which needs to be implemented, and this is abstracted by the SDK, so the SDK can be used. So then next step is that we need to validate this token. So how are we going to do that? So to do that is we use a middleware class. So in our reference server, we use our StellarOut middleware class, which receives the request. So we take the token from the request, and then we have a PHPAnchorSDK class, a helper class, which gives us the possibility to validate the received token. So here it needs the token, which was in the request, and then also the signing key, which is a part of the configuration. And now it can validate if this token was correctly signed, and it can decode the token, which is then attached to the request and sent to the next controller. So for example, here, if we look to the implementation of SEP-12, so here we have a similar concept. We have a customer controller which implements the Stellar specific functionality for SEP-12, know your customer, but it has the middleware set to StellarOut middleware. So here we validate if the token is okay, and if it is correct, if it is correctly signed, then we decode the token, and the contained data is then sent to this customer controller, so he can check if the request corresponds to the data which is encoded in the GVT token. So here I have a short test, so we can see what is in the in this request parameter StellarOut, which we know from here. It's we put it here in the middleware, and here we can just in the controller in this sorry, routes API in this route test StellarOut, we have the middleware attached. So it uses the StellarPHPAnchorSDK to validate the GVT token and puts the data here into this, and the route is just returns the values that are stored here in this array. So let's have a look what happens here. So if we take the GVT token and send it to our test, so we put it here as a Bira token into the request. Now we can see how this is composed. So what is inside the GVT token? So now we can see here that the GVT token belongs to this account, and So if we use this GVT token to, for example, try to put another customer with another account, it will not work because the GVT token corresponds to this user. So, and this is the contents can be very different. So, for example, if I have if I identify with an account and a memo, it will also contain the memo. Like, for example, let's have a look here. We add here a new parameter, memo, and let's take an other account which is easier with the signatures. So we have this transaction, and now let's sign it. So we post it back to the server. Now we get this GVT token. So now the account is identified by this account ID and the memo. So if we now take this this token, the new one, we can see here that we have the memo also. We can also, for example, identify with a Marked account. So like, for example, we have here, let's create a new one, this one. And now we say, okay, create multiplexed account with this as an account ID. So we have this one. And now we would like to put here, we don't need the memo anymore because it's already included in the account. Okay. Which one did I use? Okay. And now let's sign this transaction. So it was this one. Do we have this one? No. Okay. No, it was this, which is FBA. Okay. Now let's sign the transaction. It was this account, so we take this secret seed. And now we should see how the how the GVT token has another format. Okay, this was not the right one. Let's try it again. So I guess I had a wrong. Let's take this one. So FP, yes, I had the wrong one. Okay. Create multiplexed account. And now we identify with this one. Here's the transaction. We have to sign it. Okay, signed transaction. And now we can send it back to the server, which has to validate it. And if everything is okay, then it needs to send us a GVT token. And now this GVT token, again, has a different information in it because it was built with a multiplexed account. So you see here, and it has the multiplexed ID like this. And this is all defined by this SEP-10. So by this standard ecosystem proposal 10, everything that you have seen here is defined by it. So here you can see now how much work the PHP Stellar SDK, Anchor SDK can take away from the Anchor developer. So it is Stellar specific functionality that, of course, he needs to understand, but he does not need to implement it again and again. So currently the PHP Anchor SDK supports SEP-1, SEP-10, SEP-12, and SEP-24. And now we can have a short look to SEP-12. I also prepared some requests here. So let's have a look to see how how this should look like. So what happens here is that first the client has to use SEP-10 as we've seen it before, to receive the GVT token, and then they can request information about the customer. And depending if, for example, if we request here information about an account ID which is not in the GVT token, then we will receive unauthorized. If we request information which is for the user which identified himself with the GVT token, it will give us the customer information, which is stored in the server for the Know Your Customer process. Now we can put data, like for example, we can put the requested data from the server. So the server can say, okay, we want first name, last name, email address, photo ID of the photo of the ID, and so on. This information is described here in this customer info, and now we can send it to the server. The server can validate the request and store the data in his database and return us the new customer ID which he created. We can then also verify email addresses, for example. So let's have a look how this works. So first we want to get custom. So first we want to get customer info for a specific account. So this means that we first need to authenticate this account. So now let's take this one, just as a simple account. We authenticate with this account. We need to sign the transaction. And send it back to the server to get the GVT token. Okay, now we have the GVT token. This means that we have passed this first step. So we have now the GVT token. Now let's see if there's any information for this user. To do that, we have to request the information for the corresponding account ID, and we have to authorize with the GVT token that we received before. So now let's go and take this account. We want information for this account. This is defined in the SEP-12. And now we can see here that the server says, okay, this customer with identified by this account ID, with identified by the GVT token, needs I need different information for him. So like, for example, I need her first name, her last name, her email address, ID number, the type of the ID. So here you can choose between password, ID card, driver's license, photo ID, front and photo ID back. So the this is so like how this result is formatted, and this data is all done by the PHPAnchorSDK. The server only needs to define the on an object basis which fields he needs. So now let's go here and fill some of these fields. So next we can see that one of the next steps is to put the customer information into the server. So he will create a customer ID, and we can see how I prepared here some things. So let's first put just the last name. We don't put the last name, so that we have something missing. We put here the photo ID from like select file. Let's take this one. Okay, and here the same, just a photo ID. And now we have to, of course, we have to authenticate here with the GBT token. So we just take it from this request. We have this body with the data, and now it sends a put request. And now this data has been validated by the SDK, has been parsed out of the request and sent to the anchor, so that the anchor server, the developer, can use the data in a very, very easy way to put it in his database. And it created the user with this account ID. So now let's get some info about this user with our account ID. So to see maybe something is still missing, we need from here the token. Otherwise, we will not be allowed to get the information. And now we can see here. So we have these fields we have already provided them, like first name, email address, ID number, and so on. These are all provided fields now. But still the last name is missing. So it is still in the status of needs information. And now we can also see here that the email address says that a verification is required. So the server sent us an email with a verification code. So this was received here. So this is the verification code. Now we can use another endpoint, which is called put customer verification, and we can verify our email address. So this was our code. The user ID is here. And of course, we need again the authorization token, the GBT token, so that to know that the user is allowed to do this. So let's put it here. So, and now we will see that the email should be verified. Where is it? Email address is accepted now because we verified it with the in a way defined by SEP-12. Okay, now we can also update the data. For example, we can now put the last name, like this. And let's see. Oh, now we have no more fields. All are provided, and the status is processing of this customer. So now the server business logic needs to find a way to put it, for example, into an administration console that somebody can check this know your customer data. So as you can see here, same procedure. We have a implementation in the SDK, which is used by the reference server. It adds the authentication middleware so that we are sure that it's the right user. And this customer controller now uses the SEP-12 service. And because this service is a little bit more complicated, we also have to provide a customer integration callback. So what is this customer integration callback doing? It is responsible for saving the data into the database. So for example, if we want to request customer data, this will give us from the database the corresponding data. Or if we want to put the information, it stores it in the database, and so on. And as you can see here, the data already comes from the SDK in a validated way and in a very easy to use way. So the Stellar-specific functionality that is needed before before putting this data in the database is covered by the PHPAnchor SDK. Yeah, so now the time is over. That's it.
Thank you so much,
Thank
Sine.
you for everybody who was watching this. And yes, please try it out. Please try our PHPAnchor SDK, which you can find here. I will send you the link. So how can I send it here, right? Yeah. Yes, it manages client domain. Everything is managed there. It covers the complete functionality of it. You have any more questions? I believe Soneso has an active SCF request about this SDK. Can you talk a bit about what the scope of that is? So what? Yes, of course. So the implementation, this first part of the implementation. So what we did here. So what we already did is we implemented SEP-1, SEP-10, 12, and SEP-24. So at least the required things. So there are still some small optional things, like for example, we can post the data with we can put the image files with SEP-12, but there is also some optional endpoint just for files, which is not implemented, but it's also not needed. It's something optional. And for example, in this, if you know PHP, you know that there's a big problem with put requests. So you cannot attach data to them. So in this case, we had to implement in the SDK an own parser, so which parses the complete request to get the files and everything. So it was a lot of work. So, and what we did is, so to be able to implement this first part, we applied for an activation award for SCF number 22, and we received this award, which was very good because with this funding we were able to implement this first part of the PHP SDK. PHPAnchor SDK. And now we would like to go to the next steps and implement more SEPs, make it more stable, extend the reference server. So for example, SEP-38, which refers to quotes. If we implement this, we also have to update SEP-24 so that it can use the quotes. So it's a lot of work still to do, but we are going step by step. And yes, we hope to get feedback and to advance with this project. Are you open to any contributions to the SDK to make a Rust Rocket port? You're not a PHP fan. Okay, I understand. So currently there are like 5 million PHP developers worldwide, and we have implemented the classic Stellar PHP SDK, which is also used a lot. And there is people, there are a lot of people who are using PHP, and what we would like to do is also to offer them the possibility to implement products that are so this is our goal. So this is our motto: make it easy for developers of Stellar projects to implement highly usable products. And this is also a goal of the Stellar network, a goal of our community. And now with this PHP SDKs, we want to make it easy for PHP developers to build their Stellar projects. And of course, we are open to different other languages. We also implemented, for example, the iOS Classic SDK, which is used by many people. It is integrated in the Lobster wallet, and it's used by hundreds of thousands of people. It has 120 stars on GitHub. Then we implemented the Flutter Stellar SDK, which is used in the Beans app. So we are open to all kind of programming languages. Hope this answers your question. And if you would like to work with us, we're looking forward to it. Yeah, so these payments are defined in SEP-31, and this is a step which we are going to implement next. Wow, that's great. Thank you. Okay, so thank you for listening, and have a great day. Thank you. Bye-bye.